Hi guys, it's me and Beans here again, reporting live from my home classroom. And we were going to take notes in class today, but then we had too much fun with Kahoot and we decided that instead you're just going to watch this follow-up video and take notes in the next quadrant of your paper that you started on Wednesday. So let us go over here, back to our Wednesday notes where we had the vertex form section filled in, but we have not yet filled in the standard form or factored form. And we're actually going to take this same exact parabola, but write it in standard form. So if you want to, on a different sheet of paper, take y equals x plus 2 squared minus 1 and multiply it all out and put it into standard form. That'll be our first step in filling out the next section of our notes. If you want to press pause and do this yourself and then check your answer with mine in a moment, that's great. So I'm going to continue. I'll use the box method to square my x plus 2. X plus 2 times x plus 2 will give me x squared, 2x, 2x, and 4. And when I combine my like terms, this will all become x squared plus 4x plus 4. So my next step, I can rewrite this as, well, let me actually show it both ways. So I could have written this as x plus 2 times x plus 2 minus 1 by expanding out this square, 2 copies of the same thing being multiplied. And if you prefer the double distribution or free throws or FOIL method, first, outer, inner, last, you should get the same products where x times x is x squared, x times 2 is 2x, another 2 times x is 2x, and then we have 2 times 2, which is 4. And then there's still a minus 1 here at the end. So any way you slice it, when you square the x plus 2, you get x squared plus 4x plus 4. Same thing I got when I did the box method, but I'm still minusing 1 from the very end because this original was a square minus 1 unit. So here's the square minus 1 unit. So my final answer in standard form is y equals x squared plus 4x plus 3, because 4 minus 1 is 3. Okay, this is now in standard form. Because general standard form is y equals ax squared plus bx plus c. And we're going to get this in our notes now. Going back here, the new example that we can write down was what we just multiplied together. Let me get my right pens. So this example, same function, y equals x squared plus 4x plus 3. Same function in standard form. I'm going to highlight this so that my examples pop. Okay. General standard form, y equals ax squared. And you're already familiar with this a variable. We already wrote it down in our vertex form. Plus bx. Do I have any new colors I can use? Plus, oh, I don't know. Light blue. Ax squared plus bx plus c. This is standard form. Drop shadow effect to that. And I'm going to use up my whole gel pen with drop shadows. Okay, what does A stand for? We already know A. It stands for whether determines if parabola is concave up or smiling or concave down, and also the vertical stretch or compression. What does B do? B is actually not that useful in my humble opinion. B it's not super useful, and that's all I'm going to write here, but if you wanted to explore what the variable b does to a parabola, I invite you to write into Desmos y equals ax squared plus bx plus c, add sliders for all, and then play with the b slider. It makes your parabola move in this weird kind of arc path. So that's actually not very useful, but the c variable is useful, and that's why standard form can be your friend. The c variable stands for the y-intercept. And the reason that C stands for the y-intercept is that the y-intercept occurs where x is 0. It's on the y-axis, and the entire y-axis is where x is 0. If you took any point on the y-axis and labeled its coordinates, it would be 0, something. So if I plugged in 0 for y and solved this quadratic, if I plugged in 0 for x, this term would disappear. I'd be squaring 0, multiplying by a, it goes poof. This term would disappear because anything times 0 is 0. So if I plugged in 0 for x, all of this would go away, and y would equal c. The y-intercept would be c. Or the point 0, c would have to be on this parabola. All right, that's about it for standard form. Stay tuned for the final installment, vertex form, coming your way Monday in class. Have a great weekend, y'all.